Let me take you to my study area. We are in the Wadden Sea, between the islands of Ameland and Terschelling. This is the Boorndiep Basin, and it has habitats ranging from high intertidal flats to dynamic gullies out through the inlets to the ebtidal delta, which is the shallow sandbank in front of the coast and in front of the Ameland Inlet. In 2018, a 5 million cubic meter pilot sand nourishment was placed on this ebtidal delta. In the Trills project, we look at where the sand goes and what it does there. And in my PhD, I look at the ecological side of things, the interaction between the sand and the animals living in the seafloor. The sediment type determines for a large part which communities we find where. Every species has their own preference for sediment type. Some like very muddy places, while others prefer sand. Also, they differ in how specialized they are. I looked at the sediment preference of species and communities and whether they live actually in their preferred habitat. And I found that overall, this tidal basin is a bit on coarse and sandy side for the communities that are living here now. In some places, for instance the areas under Terschelling and under the head of Ameland, the sediment is especially coarser than the optimal range for the benthos. We cannot link this to the nourishment, but for future coastal engineering, we should keep in mind that if the basin turns more sandy, the sediment habitat might become less suitable for the communities currently living here. But why do some species like sand or mud? Let's zoom in on one particular clam, the peppery furrow clam, or in Dutch, the platte slijkgaper. We find them in quite muddy places. But what's the reason for that? Is it because here they find more food? I studied whether the animal was performing better in sand when there was more food available, and in which sediment food habitat it was most resilient to heat waves. Even with enough food, they still survive better in mud than in sand. And not only does sediment type affect benthos, also the animals themselves can influence sediment transport and composition. For instance, by the structures that they make. Shells remain in the sand for a long time after the animal that has produced them has died. I looked at how different shapes of shells influence current-driven sand transport. Shells increase the roughness of the bed, while they also trap sand under them. With enough shells present, less sand was transported than in a seabed without shells. This goes up for both long and round shells. Besides sand transport over the bed, animals can also transport sand vertically into the seafloor, and in that way influence sediment composition. They can do this by their activity, their burrowing activity, or so-called bioturbation. And each species has its own way of moving through the sediment and feeding. Some are diffuse bioturbators, while others convey sand upwards or downwards. In a field experiment, I tried to quantify this bioturbation by using different tracers to follow the sand. When you have information on the composition of the entire community, then you can predict how much sand will be bioturbated, how long it will stay on the surface, and how fast and deep it is moved downwards. So let's zoom out again to the Wadden Sea. With sea level rise, we will need more nourishments and coastal engineering interventions if we want to protect our coasts. These benthic animals living in the seafloor, shape the soft bottom habitats, and they are key in this productive Wadden Sea ecosystem. Therefore, we should study carefully what happens to them when we play around with sand. I hope you take away from this short overview that benthic animals and the sediments they live in are important for each other.